Okay, so I'm going to look at example 2 now on the sheet. Example 2 says a particle P is 100 meters due west of another particle Q. The velocity of P is 6I plus 2J, and the velocity of Q is minus 4I plus 2J. Heading off in that direction, minus 4I plus 2J. Show that P and Q are on a collision course and how much time will pass before collision and what position will it happen at. Okay, so if they're on a collision course, remember the slope of the relative velocity must be equal to the slope of the relative displacement, and I'm calling the relative displacements R. Okay, so let's get all the information first of all. What's the velocity of P? Velocity of P, 6I plus 2J. Velocity of Q, minus 4I plus 2J. What's the position of P? The position of P is 100 west, so if I do it in terms of I and J, that's minus 100I plus 0J. And what's the position of Q? Is at the origin. Okay, so I shall get the VPQ. So the VPQ will be VP minus VQ. So that will be 6I minus 4I will give me plus 10I. And 2J minus 2J would be 0J. And if I do the same over here, what's the RPQ? The RPQ here will be minus 100I minus 0I, which is just minus 100I. And of course 0I minus 0J will just give me 0J. Okay, so what is the slope then? So the slope of 10I plus 0J. Remember 10I plus 0J would just be along the I-axis like this. And the slope, this is my VPQ vector. And of course, where's the RPQ vector? It's in that direction. So we can see that they're both on the I-axis. So obviously they're parallel. So their slopes will be the same. But just to prove it to us anyway, the slope will be the J's over the I's, because it will be the tan of the angle that it makes with the I-axis, which of course is 0 here. So the tan of 0 will be 0, so that will be just 0 over 10. And this one, of course, the slope of RPQ is also 0 over minus 100, which is 0. So they've got the same slopes, so therefore there is a collision. So we've shown there is a collision. How much time will pass before collision? Okay, the time to the collision, remember, is relative displacement over relative velocity. Relative displacement over relative velocity. But of course, I'm going to get the modulus of those. And when I get the modulus of relative displacement, I'm getting distance. And when I get the modulus of relative velocity, I'm getting speed. Okay, so this one becomes relative displacement. We know that what that is minus 100I plus 0J. That's the RPQ, this one. Divided by the relative velocity, I know what that is. It's 10I plus 0J. And if I get the modulus of both of those, this will be the square root of the I coefficient squared, which is the square root of minus 100 squared, which of course will just be 100. And this one will be the square root of the I coefficient squared, which will be the square root of 10 squared. Okay, so that will just become 100 over 10, so that's 10 seconds. So my time to collision is 10 seconds. Now, where will the collision happen? That's the next part, position that it will happen at. So your position of your collision. Okay, so now I want to find the position of the collision. So remember, I'll just take P. So what's the position of P? P is at the position minus 100I plus 0J. And if I use the link, the speed is equal to distance over time, which means that speed or velocity multiplied by time will give me displacement. So if I use that idea to do this bit, so I'm at minus 100I plus 0J, that's where P is at the moment. His displacement will be velocity multiplied by time. So his velocity of P is 6I plus 2J. and I'm going to multiply that by 10 because this happens after 10 seconds. So minus 100i plus 0j plus 60i plus 20j is going to be my new position. And when I do that, I get minus 40i plus 20j. And if you did that for Q, you'd get exactly the same thing. So this is the position of collision, and 10 seconds is when collision happens.